Good morning, everyone. I hope that, good morning. I hope that a reasonable tone of voice from my end will come out as a reasonable volume at your end. Excellent, thank you, appreciate that. Yeah, anybody who can't hear me, raise your hand, right? That never works, but you guys let me know you could hear me, so thank you for that. And thank you, Joe, for the introductions, I appreciate them. It's a pleasure to be here. I had actually hoped to be here last year, but I had the joy of sitting in an endodontist's chair getting a root canal instead, and it was much less pleasurable than I'm sure this event's going to be today. It really is a privilege for me to be here. I've had a privileged life, though. You heard, I got to work in over 20 different countries. I've got to work in every major industry sector that there is as a technologist, and I am a technologist, a recovering software engineer, as it were. And I still see the world through the lens of software engineering. I know its limitations, mind you. I know what it's good for and what it's not good for. But I share that with you because it's important for you to understand my perspective and have that context for the remarks I'm going to give you today. I like to start with context, and so that's what we're going to do. My context is, for today's discussion, digital transformation in government. Now, digital transformation is a term that's been around for a little while. I think it's helpful for me to declare my vocabulary to you, and so that's what I'm going to start with. For me, the challenges of digital transformation in government come down to the left and the right side of the slide that's up in front of you. On the left side, we have the expectations that government employees, whether they're in uniform or not, whether they're contractors or not, the expectations that they face. And it's a treadmill of constantly changing expectations. Whether it's the acknowledgement that every day taxpayers and citizens get new expectations for personalized service, digital access to personalized service, and those expectations are set by the commercial sector. Whether it's your interactions with your bank or your interactions with your retailer, you expect digital access to highly personalized services, and then we all bring those expectations to our interactions with government. And that is a treadmill because those expectations are raised every single day. Whether it's new fiscal years and new budgets, whether it's new major initiatives like the Build Back Better, whether you like it or not, these kinds of challenges constantly raise the bar for government in terms of delighting citizens and delighting the stakeholders. On the far right, what we have are the current administration's list of priorities. They have reformed the regulatory process to identify a new set of goals which they deliberately describe as difficult or impossible to measure. And this is in a context of evidence-based decision-making. And yet we now have goals that we acknowledge are difficult or impossible to measure, whether that is racial justice or human dignity. Now, as somebody that has also worked as a data scientist, the thought of modeling and measuring human dignity is a non-trivial exercise. But this is now the exercise in front of data practitioners in the government space and who serve the government space. So how are we going to cope with this treadmill of rising expectations and deliver on these really difficult to measure outcomes, which are actually desirable, hard to argue with? Well, we've identified 5 vectors of transformation, and that's what's in the center that you see. That's what's going to get us from the left to the right. And those 5 vectors of transformation are really easy to describe, and so I'll do that, and then I'll acknowledge that they're really hard to do. But let's talk about the 5 vectors quickly. First, always first, people and culture. The question becomes, how do we shift people and culture from just experience-centered decision-making, which is a great strength of the DoD. I saw that myself every single day when I went to work in the Pentagon. How do we transition from experience-centered decision-making to evidence-centered decision-making? And it's not an either or, it's an and, by the way. How do we add evidence-centered decision-making to experience-centered decision-making? That's the first vector. The second vector of change is processes. How do we shift the processes, which today are still incredibly manual and fragmented, with lots of disconnects and human beings cutting and pasting? from one screen to another screen. How do we change that to digitally integrated processes? And as a software engineer, I do not recommend system integration as the solution to that problem, by the way. I recommend data integration as the solution to that problem. What about policy? Got to get policy right, because policy is often the barrier to change and improvement. So how do we take policy from static to dynamic and make policy machine readable right across the patch in a way that it's long been machine readable in cybersecurity, right? We can write policies for access controls, put them on every firewall in the organization instantly, and have them take effect. Well, how do we do that for all of the other policies? The DoD at the OSD level has over 1,800 policy documents, 125,000 pages of policy documents, 6 million words. Do you think any human being comprehends the breadth and depth of that? It's simply not possible. So we have to go away from 125,000 page images in PDF format into something that's machine readable. Fourth vector, partners. There's a tendency in government, and I know this will shock you, to take the choice of safe partners, predictable partners, people in the Gartner upper right-hand quadrant, in the Gartner Magic Quadrants. And if you take safe, predictable partners, you get very limited results. That's just the nature of the world. Low risk brings low reward. We encourage folks to take a more dynamic approach. If you want breakthrough results, you're going to need breakthrough partners. And I'm not talking about me, I'm talking about the bigger picture. If you do what the DoD did and you take your human capital management for your civilians and you move it into software as a service, that vendor, which happens to be Oracle, becomes a business partner for you because you can't operate without them. If you move your financial management into OneStream, another software as a service vendor, you can no longer perform financial management without them. And that's the best way to get best in class. Okay, so now they're my business partner. I need to treat them accordingly, and I need breakthrough partners because I want breakthrough results. My last vector, now this is my home as a technologist, and I am still a hands-on technologist. It's shifting the tech portfolio away from 100 or 200 or 300 GOTS and COTS implementations in on-premise data centers onto the latest and greatest platforms. Software as a service is an example of a platform, so that I get the latest and greatest commercial sector best practices, because that's what I need, right? That's what the President's management agenda calls for, that every business function in government will perform as efficiently and productively as in the commercial sector. Okay, well, how do you get there? You take the commercial sector platforms. It gets you there instantly. These 5 vectors are not unique. Any one project will involve a mix of them. Any project that does not involve the full mix has a lower probability of success than if it involves all of them. But I wanted to give you that context. Now, the edge of technology, which is the theme of our conference, comes in this last vector. So what I'm going to do is I'm going to double click a little bit on this vector, and then we're going to get into the technology at the edge. So first, what do I mean by this move to tech platforms? You'll notice that it actually doesn't say tech platforms, it says tech squared platforms. And that's because it's not just technology that matters, it's the techniques involved in deploying the technology. Right? Cloud is great, but cloud without the DevSecOps technique is not so great. Well, you need both, and in fact, DevSecOps is the gateway drug to cloud. Right? Developing brand new applications in a cloud native environment, you're going cloud fast. If you do it any other way, like the NIST suggestion that you lift and shift something, you're going to go to cloud very slow because the nature of the thing doesn't change. All right, so tech squared strategy. I'll list a bunch of context things on the left side of the slide. This is kind of a similar build to the previous one, but you know the ones on the left side. I don't need to belabor those. Let's talk about the goals on the right side of the slide. What you're trying to do as you adopt tech platforms is getting access to innovative ecosystems and the data in those innovative ecosystems, right? Outside data as well as inside data. Yours as well as other people's data. That doesn't mean you have to share yours, mind you, but when you get into one of these platforms, you do get access to a broader set of data and benchmarks for performance that you didn't previously have access to. You're trying to get to reduce friction, which means every transaction, every interaction happens faster because it's happening through code. It's happening through automation. So you want reduced friction. You want the ability to scale to any size and speed when you need it, so-called hyperscale capacity. It doesn't mean you're going to use it all, but you pay by the drink, so it's okay that you don't use it all. And when you need it, you want it immediately available. I don't know of a single on-premise data center, and I've worked for companies like Hewlett-Packard Enterprise. I don't know of a single on-premise data center that has unlimited capacity. But every cloud vendor of the Big Four can give you that. It's there. You just tap into it. You don't even have to ask permission. And I'm in a private data center. I got to go buy hardware, get it shipped, get it in the dock, get it in the rack, turn it on, load the software, all that stuff, and it's now 18 months later. That's not what I want. What I want is instant hyperscale capacity. I want accelerated learning curves, because when I'm in one of these platforms, I get the advantage of all of the learning that that particular vendor gets from all of the other customers in the platform, right? That's non-trivial. That's called a network effect, and the benefit of any network goes up as more people participate in that network. And finally, I want complexity management. I want really effective complexity management, which again, these platforms bring. So that's for any kind of a platform. And I'm going to talk about a bunch of different platforms for a minute, because every part of the enterprise should be moving into a tech squared platform. Those platforms are, at the 12 o'clock position, omni-channel. And by the way, this is not a list of products. My company doesn't make products. We don't sell products. So I want you to understand that this is what this is. This is a list of services you can subscribe to from those breakthrough partners. So at the 12 o'clock position, the omni-channel platform. This is your engagement platform for people, whether they're warfighters, citizens, employees, contractors, stakeholders on the Hill, doesn't matter. If you're interacting with human beings in the commercial sector, you have an omni-channel platform. And it brings together a view of every interaction through every form of digital media, whether that is a phone call, a text message, an email, a visit to a website, a visit to Facebook, whatever it happens to be. An omni-channel lets you build a 360-degree view of the human beings you're serving so that you can provide digital access to personalized services. That's what omni-channel is all about. At the 3 o'clock position, we have the intelligent edge. And this is the engagement platform for things, as in the Internet of Things. So if it has a chip and if I can connect to it, I need an intelligent edge platform to manage that, to help me pull the data, pull the right amount of data, to help me respond in real time when things happen at the edge, because I don't want to have to transmit data in order to respond at the edge. I want to be able to respond in real time. Look, as a technologist, I measure distance in milliseconds of propagation delay. And so real-time response means not moving the data in the first place. It means dealing with it at the edge, which also means pushing algorithms onto those chips at the edge. We'll talk more about that in a minute. At the 9 o'clock position, we have the transaction engines. And this is where those software as a service offerings live, like the the PeopleSoft software as a service, like the OneStream corporate performance management as a service, those kinds of things. When you're dealing with the velocity of business transactions, you want to be in the transaction engine platforms, and you'll have a set of them. We're a digitally transformed company. We walk the talk. We have a number of software as a service subscriptions ourselves. That's just the nature of performing as a leading company now. At the 6 o'clock position, hybrid cloud. And look, there's a little bit of a blur here because, of course, if you're on a transaction engine and software as a service, you're in the cloud. But if you've moved your other applications yourself, or you've created new applications yourself, you need a hybrid cloud infrastructure because you're going to have data on multiple platforms. And you need to secure it in multiple places. You're going to have workloads in multiple places. And you need to secure and manage those. So you need a hybrid cloud capability, hybrid cloud management fabric. And then in the center, of course, analyze for impact. This is where the data scientists get to play and the analysts get to play. This is where I'm going to have my data sandbox. I'm going to bring a lot of different data together and a lot of different tools. Those of you who are familiar with the DoD will have heard of an example of this called Advana, which when I was in the DoD, I helped the comptroller build. If you like it, give the credit to Greg Little in the comptroller. If there's something about it you don't like, you can blame me, and it's all fine. But you do need to bring that data together. And as I told you before, as a software engineer, I do not recommend system integration as a way to get the data in one place. I recommend data integration and the use of data fabrics. So these are the 5 platforms, all supported by some effort for secure enterprise integration, of course, because I need to manage it all. But what we're going to double click on is the intelligent edge, because after all, that's part of the theme of our conference over the next 2 days. So let's do that double click. I'm going to go through the what, the how, the where, the why, and the who. This first slide is what do we mean when we talk about intelligent edge? And how do I deploy an intelligent edge? So on the left is a visual of the various types of sensors, monitors, SCADA gear, PLCs, you name it, that make up the intelligent edge. And the reality that there are a number of tools and techniques that we're going to come to in a little bit that help me pull all that together, that help me manage the data flows, select and sort that data, select and sort where to put my machine learning algorithms, manage those machine learning algorithms through their life cycle. That's probably a bigger deal than creating them in the first place, and optimize the data, optimize the analytics of that data as well. On the right-hand side, it's what are the capabilities I need to do that? How do I go about getting this done? So I need to think about this as a future mode of operations because you probably don't have it all today. You may or may not have a set of data engineers who understand SCADA, that's supervisory control and data acquisition devices, and programmable logic controller devices and sensors. If you don't, you'll need a set of people to do that. And you'll need a set of algorithms that are specific to those domains. And the people who are nodding their heads already know this. I can see the light, I can see the recognition in your eyes. Oh yeah, we're already facing that problem. But it's part of the how. You need a pipeline for deploying algorithms out to the chips. So the MPUs, the TPUs, the A14s, whatever chips you happen to have, you want to be using the latest low energy consumption, high power chips capable of running algorithms for you, simple machine learning algorithms, so that you can process that data and respond in real time, which then means that you need a deployment pipeline for those algorithms, again, lifecycle management. You want to make sure that the whole organization is using common utilities for a number of things, whether it's GPS or whether it's date and time, it doesn't matter. This is not classified information, what I'm about to say, but there is a branch of the military that has weapons platforms that use different GPS coordinate systems. That couldn't go wrong, could it? So you need common utilities for these things. Look, data is not just numbers. Data is numbers with context, date, time, place, that's the context. And it's only valuable when you have the context. The context only matters if it's common, therefore you need common utilities available as services, proven code. Training quality data sets is another element of this. Training as in training algorithms. Training quality data sets really critical challenge because all data is incomplete and all data is noisy, all data is dirty. The question is not can we get to perfect data, it's can we get to good enough data for our purpose. So I need my training quality data sets. And you'll hear Dave Spurk, who took over as the Chief Data Officer of the DoD from me, often talks about this issue of data quality and training quality data sets. And there's a bunch of data engineering that's required for that. And then of course, you want to inculcate this culture of actually evidence-centered decision-making. Right? That's a legal term defined by HR 4174, the Foundations for Evidence-Centered Decision-Making Act. But statistics come to the fore here, right? So we're back in that people vector, people and culture vector. Right? So when I say what and how around the intelligent edge, this is what I'm talking about, what it is and how you go about creating and managing it. Let's spend a minute talking instead about where is the edge, as in where's the bleeding edge of both techniques and technology for the intelligent edge today, and where's it going to be tomorrow. Look, I work for a company that is vendor neutral. And I've been in vendor-neutral companies for a long time. What I also know is that the market's never vendor-neutral. A couple of firms will dominate a market. But it's my job to give unvarnished, fact-based advice to people, whether they want to hear it or not, because that's my job. If I don't provide fact-based advice, then I'm acting without integrity. So given that I care about technology and I care about techniques, let's talk about where the bleeding edge is, because I actually kind of like solving hard problems with bleeding edge technology. That's where the interesting challenges are. Today's bleeding edge for the intelligent edge, obviously IoT. Rapid advancements, new devices all the time, new data types all the time, IoT. Drone management. There's a lot of software available to manage drone fleets and to coordinate their activities and controls. There's been drone suppression capabilities out for a long time. Every NFL stadium has drone suppression systems implemented. It's a requirement of the NFL. It's been that way for at least 5 years that I'm aware of. So drone technology is not brand new, but I happen to know that there's still a number of bases and installations that are suffering drone incursions. It's being tracked on an ongoing basis. Right? So whether it's your drones or other people's drones, drone management becomes really important. The digital sensors speak for themselves. The digital SCADA speaks for itself. The smart buildings, yeah, we don't have a lot of smart buildings yet. We talk a lot about smart buildings and smart cities, but most of them simply don't exist. Most of the warehouses and maintenance depots are incredibly under-automated in the DoD and in the federal government compared to the commercial sector. If I go into an Amazon warehouse, and you don't have to physically go in if you don't want to, you can actually watch the videos on YouTube. They're highly digitized. They know where every single thing is. They get no shrinkage in a data center. I know of a large number of DoD data centers and maintenance depots where we literally don't know what's on the shelf. We don't know how long it's been there. We don't know when it came in. We don't know when it's going to go out. We don't know how much of the space is empty. Now, I happen to think that not every commercial sector behavior belongs in the federal government, especially not in the DoD. I had people in the Defense Innovation Board complaining that there were 40% spare capacity in warehouses in the DoD. I said, yeah, that's called surge capacity. We don't take that out. We need buffers. You need that surge capacity if you're the DoD. So we don't want to run at the same efficiency measures as the commercial sector does, but we do want to be efficient and we want to be highly automated. So if we look ahead into the future, where's the bleeding edge that we can see coming out of the commercial sector that's useful? Well, the NPUs, TPUs, these really low power, high performance chips that I can put algorithms on. Number two, visualization from a geo perspective. Saw an interesting display out in the hallway, by the way, of some nice folks that can turn 2D into 3D imaging, which is going to get really interesting, especially in the facility space. Qubits and the whole quantum computer space. Promises to be able to crack every encryption code in way less time than we thought. Qubit computers are really interesting. They're on the edge of science fiction when you read about them, but we're seeing incredible results from those. And they give us a kind of number crunching capability we never had before. That's an existential threat, by the way, to every encryption algorithm that we have today. Qubits, and qubits as an example of quantum computing. 5G implementation services, 5 times the bandwidth, I think it's 6 times the bandwidth from the 4G and the 3G. It makes a lot of things possible that weren't possible before, because now I can deliver real-time information to people in physical locations I could not deliver real-time information to before. So now I can move artificial reality onto the plant floor, into the warehouse floor, and provide real-time information to people. 5G is going to be a game changer for a lot of different things. and it's going to change the rate at which we do things out at the edge. And then finally, the whole set of analytics design services around edge computing, because this is relatively not well known. Look, we spent the last 15 years moving things into the cloud, centralizing them. Now we're going to move compute and workloads. Let me rephrase. We're not going to move compute and workloads. What we're going to do is automate new workloads at the edge of the enterprise. These will be new workloads we haven't automated before, so we're going to learn a lot about them in real time, because we're going to be directing things to move and change in real time. If you're directing a PLC or a SCADA device that is controlling the feed rate on a belt or the energy level going into a pump or into a heater, well, you better be monitoring that in real time and changing that in real time, because otherwise things get out of control pretty quickly. So let me move from the where is the bleeding edge to the question of why. Why do I talk so much about the intelligent edge? And it comes down to simple economics. A lot of other people are spending money, so you don't have to. They're spending money to create innovation, services, and capabilities, push adoption of those, create innovation with those, all of which you can simply take on and use without having to provide the innovation, support, and R&D yourself. Look, a lot of money goes to the nice people at DARPA, and they do fabulous work. DARPA and the entire federal government's innovation R&D spend is a tiny fraction of what Silicon Valley is spending these days. You can't afford to ignore that source of innovation. So the why it matters is you can ride somebody else's R&D money. So let's look at some of the examples. Number one, a $500 billion market. That's a lot of spend that's fostering additional innovation. So customer spend turns into innovation and additional R&D. $500 billion last year. Over 50 billion IoT devices out there. Now, I mean, they're tiny. Often comes down to just a chip, but 50 billion devices. That's a lot of data. It's a lot of a new sense of the real world that you didn't have before you can tap into. Look at a specific example like smart cities, $237 billion. Okay, there's some interesting innovations that are happening out there if you're tracking that space. Motion detection and recognition. My friends, I have no polite words for this, so I'm going to have to measure myself here. This is horse pucky. But be aware that people are throwing money at this horse pucky. Maybe it'll produce something good, but right now, don't put your money there. Let other people put their money there. And then, look, in just 3 years, we're going to see an enormous number of NPUs and TPUs out in the real world. Other people are putting them out there for you. So 1.4 billion to add to the 50 billion IoT devices already out there. Honestly, is that exciting? Well, it's going to be 3% of the total devices out there. Now, in percentage terms, it doesn't sound interesting, but 1.4 billion TPUs and NPUs, it's a lot of opportunity for innovation. And you don't have to do it all yourself, right? You can learn from these other folks. And then that bar chart over on the right-hand side, that stacked bar chart, that's the so-called fog market, which is where the cloud starts to dissipate into the intelligent edge, right? Who gave us that? That is from ZDNet, and $18.2 billion in spend. A tiny fraction, really, but that's just right at that intersection between the two where your coordinated data flows in and out. Okay, so let's talk about the how slide. The how of the intelligent edge, as in, how are you going to take advantage of this? There's a handful of questions for you to take away and consider when it comes to your own organization and how you're going to go about getting value out of the intelligent edge for yourself. I'd like to just focus on 2 of them with you today. The question at the top of the list, if you think about the geographic edge of your enterprise, where does real-time image recognition matter? Where can it give you operational performance improvements? Whether it's recognition of an item on a manufacturing line and the ability to spot defects in real time, which pharmaceutical manufacturers are using, which automotive manufacturers are using, which a number of others are using, but it can be useful anywhere. And it doesn't have to be parts, it could be vehicles, it could be people, it could be any number of things. Where would real-time image recognition create operational performance improvements for you? An interesting question to ask. The other question I would like you to ask yourself is the one at the bottom of the list. Where would the workers in your field force, anyone not in an office, benefit by being able to get augmented reality support? Heads-up displays of parts of diagrams, of guidance, of videos that would enable them to do more with less, be able them to perform better with less. Enabled now by the combination of the chips and the 5G and the other technologies, because that's now easily possible. Now, there are a handful of other really, really good questions in the middle, and I will leave those to you to consider for yourself. But ask yourself how. How can I take advantage of the money other people are spending on innovation at the intelligent edge and ride that wave of innovation for my enterprise? Now, the who. Let's talk about who's who in the world of the intelligent edge. And I have a pair of slides for you on who. The first thing I want to draw your attention to is the structure of these market maps. There are clusters of capabilities that represent microsegments of the intelligent edge market. And then within each of those clusters, I show you a bunch of logos and brand names of the leading firms. These are all firms with offerings at general availability, meaning you can subscribe to them or buy them today. I own stock in none of these, by the way. But these are all going concerns, and most of them, if you go to their website, you'll be able to do a self-serve demo. But these are well-established firms at the bleeding edge of technology, widely adopted in the commercial sector. So in the upper left, we have the whole group of wearables. We're all familiar with those. I've got a smartwatch, so-called, on and a phone. Both of them track my steps. Okay, fine. Wearables. Wearables have been around for a little while. The connected home, the connected car, and car fleets, which is going to get really interesting as the Biden administration carries through on its promise to completely electrify the 475,000 car fleet owned by the federal government over the next couple of years. That's going to change that space dramatically. IoT infrastructure and sensors, the whole UAV and drone space. And then we get into some specific areas where people are doing things that are tightly focused. And more, these vendors are data science firms. They're rolling out ML algorithms and AI algorithms. And the rule of thumb, if you only remember one thing ever about AI, it's that general purpose AI is a failure mode. We do not have general purpose AI. All the action is in narrow, tightly focused AI. And so you're going to see a lot of these industry-specific spaces. So whether it's healthcare in the lower right, or whether it's utilities and energy, or whether it's industrial IoT, or whether it's retail, there are more and more vendors that are targeting just a precise, narrow niche, and they have incredible capabilities. The challenge, of course, is finding the ones where the niche matches your requirements. The second group of vendors I'd like to talk about on the intelligent edge space is this. Had a bunch of conversations with people this morning about 3D printing, right? So upper left-hand corner, 3D printers, but at the industrial scale, not at the consumer scale of things. Now, 3D printing software is itself its own special niche, and that's in center. Then we have the wonderful world of industrial robots. Yes, we actually have a very large number of robots now deployed in the real world, and not just the Roomba vacuums, but a large number of industrial robots. Robotic operating systems, it's separate from the manufacturing. We're going to see this diversion happen for a couple more years before we start to see consolidation of hardware, software platforms together. Predictive maintenance, IoT infrastructure, human-robot interaction, a lot of interesting different spaces, but the vendors that you see in each of them are well established and known for strong market positions in their niche. Now, these are small niches, but they're still quite lucrative given the total size of the intelligent edge market. If you're interested, all of these market maps come from a company called CB Insights, which in my opinion is the leading market analysis firm in the tech space today. I used their services when I was the Chief Data Officer of the DoD, introduced them there, and we're seeing wide take-up. They have millions of customers now, but that's my source for that, is CB Insights. So I've talked about the what, the where, the why, the how, the who of the intelligent edge. I hope it was useful for you. I know we've made some time for questions, and let's see. Tim, you're coming back up? Okay.
Yes, sir, I am. So we'll flip a chart, and there's a QR code. Some folks online have already jumped on it, but there's a link. You can go to the Slido and the number to ask your question. And also, for those in the hybrid format and the virtual format, just click in the Ask a Question portion. But we had an early adopter online ask a question. We got a couple, but we only have time for one. I apologize, sir. But you're going to be around, right? So,
I'll be around.
Okay.
I'm here both days.
So we have a question around, you mentioned data integration as key.
Yes.
How do you cut through the functional stovepipes and isolated data that drives a lot of the DoD data space to get to that integration point?
So, interesting question, because it's primarily not a technology question. It's primarily a process question. We had actually quite good success when I was in the DoD in doing that in a number of areas around cost management. And what it came down to is you start at the top. You start with some executives who have critical business questions they want answered, and you got no answers for them. And you work with those executives to get clear, crisp definitions of those critical business questions, because fundamentally they're use cases. And then with their action officers to identify the authoritative sources. SORNs, despite the term, System of Record Notification, SORNs are not authoritative sources. This will not endear me to a number of people in the DoD to say this, but it happens to be true. You don't want the systems, you want the data sets behind the systems. All right? But those action officers will help you find the system owners will help you find the data owners, and that's who you want to talk to, because you can't go into anybody's data center and grab their data. They're going to have to cooperate. So now you're going to go have a conversation with the data set owners about the fact that their boss's boss wants answers to some questions. Here are the questions. We would like to get a download of your data, please, because most of those systems won't support application program interfaces. If they do, fine, but most of them won't, and so you're going to have to get batch copies of the data. Batch jobs stood up to copy that data and FTP it to your data sandbox on a regular basis. To get them to do that, you're going to have to sign a memorandum of understanding, because today the data governance is not digital in the DoD, but you could go there if you wanted with your data catalogs. You're going to have to sign a memorandum of understanding that shows that you're going to treat the data appropriately and with respect, and you'll secure it appropriately and limit the access to it. That typically can take a few months to get, but once you've got that in place, then they'll start FTPing the files to you, or they'll open up their APIs, and you can start to pull it in. But it's fundamentally about, look, we have executives who want answers to these critical business questions. Your data is part of that. We're going to have to standardize your data. I want to tell you up front, we're going to have to standardize your data so that we can combine it with other people's data. We'll get you to validate that we've standardized it correctly, right? As the data owner, you tell me whether I got it right or not. But then we're going to put it all together in a pile. We're going to start to grind it to answer questions. The data owners are always going to have to be comfortable along the way. They're going to have to know that you're going to treat their data with integrity and respect, and that you're not going to misrepresent it. I will tell you that there is nobody I ever spoke to in the DoD in 2.5 years who trusted that other people would not misuse their data. Right? OSD is going to misuse it, Congress is going to misuse it, CAPE is going to misuse it, Comptroller is going to misuse it. They're going to do terrible things to me. That's just going to be part of that exercise. You know it, I know it. Go in expecting to have that conversation as well. I hope that's a helpful answer.
Yes, sir. So Okay, we've been getting some good questions here. So one more, just a encore question. Basically, can you talk about the chip shortage and the TPU, NPUs that you mentioned? Where is the United States positioning itself to be competitive, particularly in the DoD space, into the future on chip manufacturing?
We are grievously not competitive. Half the world's chip manufacturing happens in Taiwan. 150 nautical miles across the Straits of Formosa from the PRC. They're our pacing competitor. They know that half the world's chip manufacturing happens in Taiwan. We are not in a competitive position. We're not in a competitive position because we have not had a whole of government response to China. We've treated industry in the commercial sector as separate from government, as separate from defense, et cetera. And that's a weakness that we have that they don't have. I'm not saying we should be like China. We should not. That's a losing play. But I am saying we need to recognize as a country that we're in a whole of country competition with those people. And that means having domestic chip manufacturing capability. Despite the pollution, we need to find ways to manage the pollution. Despite what it does to the air and the water, we need to have a domestic chip manufacturing capacity. Everybody that consumes chips, which is every part of industry today, is suffering from shortages. GM, Toyota, et cetera, are shuttering their manufacturing lines off and on, and have been for 18 months because they can't get enough chips. We are trying, as a defense force, trying to come out of a world where we had our own trusted fabs, which kept us a decade behind the latest state-of-the-art chips, and consuming commercial chips at a time when there's a shortage. We need domestic manufacturing capacity for chips, and we need it as a country, not just as a federal government or as a DoD. That's going to require a lot of movement in a lot of places to do that. But the chip shortage, by the way, is not vanishing anytime soon. And the minute it actually begins to see some relief, we'll see, there's a pretty good chance we'll see China throttling some of the rare earth minerals production, which they control 80% of the world's supply of today. And of course, you need those rare earth minerals to make chips and batteries and other things like that. So we're in a vulnerable position, and we let ourselves wander in a vulnerable position because we had our eyes someplace else instead of on the prize of this. And I worked for HP for a few years, about a decade. A lot of their gear is manufactured in China. They're not the only ones. Every vendor manufactures in China and other places, not here. And we need to have more of that manufacturing here. I feel like I may have exhausted that question.
Yes, sir. So again, please show our appreciation for Mr. Conlon. Thank you very much for your presentation. And we get an encore presentation. I think you're going to be sitting on a panel later in the agenda. So
I am, yes.
Thank you very much.
Thank you all for your time this morning.